Hello, it's Mr. Burkhart here to tell you about transistors today. Um, to start with, this is a picture of a really old television, and on top of that, you can see what's inside. So it's actually what's inside of a really old radio. It's kind of the same idea. Um, long time ago, when technology was new, they used vacuum tubes to um, act as switches and things inside old televisions and radios to make them work. This is what they look like. They're big, giant tubes uh, in a vacuum. And basically, if you applied a voltage to what was called the grid in the middle, it would turn them on. And then if you applied the negative voltage, it would turn them off. So they just acted like these big electronic switches. Um, they burned out. They had to be replaced a lot. They couldn't make them very small, and so televisions and radios had to be pretty big. And in 1947, the team of William Shockley, John Bardeen, and Walter Hauser co-invented the first transistor, which was a semiconductor device. Here's a picture of possibly the first transistor ever created, and you can see it is a thing of beauty. Basically, they started with germanium, uh, and what is used for transistors are basically elements in the carbon family. The carbon family and the periodic table, those elements all have a place for four chemical bonds because of where they're at in the periodic table. And so they're all chemically similar. That's what makes them a family or a group on the periodic table. Germanium was used first. It's probably more rare than silicon. Silicon's a pretty common element. It's basically in every rock and sand, and it's everywhere. They have four outer electrons. Um, and as such, silicon then is by itself, it's not like a very good conductor because all of its, when you put a bunch of silicon atoms together, they form a matrix, and there's not a lot of all the bonds get filled from their partners in covalent bonding, and there's not a lot of extra electrons for knocking around and flowing. But if you dope silicon with phosphorus, which you can see, phosphorus is here in the next right next to silicon. So it's pretty much the same size as silicon since it's next to it, and if you but it has an extra electron because it's in the next group. The next group they all have five instead of four, and so that gives an extra electron to the matrix, and now there's an extra one floating around that can travel. If you want to, you could use boron to dope it as well, and boron, since it's one group behind silicon, only has three electrons, and so now there's a hole. There's a place where an electron needs to be, and so this would be like a positively charged uh, semiconductor, and this would be a negatively charged semiconductor. And yeah, let me see. And now I have to figure out how to get rid of the pen. So that's cool. All right, maybe that'll do it. Yay, it did it. All right, if you put these together, Um, silicon is cool. It acts like an insulator. It doesn't allow current to flow. But when you, oh, I need to get rid of these. These are still here. Well, that's not good. There we go. All right. Um, when you put an N type or a negative type semiconductor and you make a sandwich, put a P type in the middle, what you'll find is that the extra electrons in the p type that are at the edge will scooch over and fill some of the holes in the p type on both sides, and then that'll cause this empty zone here that electrons it's like a barrier that electrons can't get through. So it's off. This semiconductor would be off. But if you bring a positive charged plate near here on the P part, it'll draw some electrons to it, and then that'll let electrons flow through. So electrons will be able to flow through. So now it's turned on. So that's basically it. This is called a transistor. This is an NPN transistor, and it acts like a switch. When the voltage is here, it's on, and when the voltage is gone, it's off. All right. There we go. It's still a pen. There we go. Okay. Here are, just for fun, some diagrams of electrical circuit diagrams for transistors as a switch. This is not the video for me to explain how this works, but you can see that they're just showing you how it acts like a switch, and it's open and closed. And then also transistors can be used as amplifiers, where they can increase an electronic signal. So those are basically the two basic uses of transistors. There are a lot of different types of transistors. The kind that we're going to use in class the most is the bipolar junction transistor. It's the one that's circled in red here. You can see it's got a flat side and a curved side, and these are really good for do-it-yourself projects or hobbies or teaching electronics. The one next to it is a FET, field effect transistor. There's also MOSFETs, then these other kinds, which frankly, I haven't loaded the information in my brain about those at this time. So but you might see, I just want you to be aware there are different kinds of transistors, and this bipolar junction BJT transistor is not the only kind that's out there, even though it's probably the only kind we're going to deal with in my class. So looking closer at the bipolar junction, it's basically got three legs on it. You can see here, let me turn the pen on. Here's the picture, here's the flat side right here. And you have to, sometimes so the base, it's the three-legged, the three-port component. The middle one's always the base. So you got that. The base is what turns it on and off, right? This is where the plate is, and it turns it on and off when it's got voltage on it, boom, it's on. And when the voltage is off, it's low voltage deal. It's on and off, on and off. So then you have a collector and an emitter. For some transistors, the collector is the one on the left and the emitter is the one on the right. But for some transistors, it's the other way around. It depends on who made it. Sorry about that. You can see we're collecting electrons here and we're emitting electrons here. So that's pretty simple as to how they named it. It kind of makes sense, right? This is the side collecting the electrons, and when we turn it on, boom, the electrons, we put that positive voltage on it, and boop, now the electrons can flow through it, and it emits electrons, and when we turn it off, it's off. It's a little switch. So going back, these types of transistors aren't really used in modern everyday. I mean, this is older generation stuff for electronic equipments from an earlier generation. We're still using them though for projects, for do-it-yourself projects, because these are the sort of things you can actually use, in your little shop if you had one, if you were into this as a hobby. But if you were in industry and you're actually making phones and televisions, they are now using little teeny tiny integrated circuits invented by Jack Kilby at Texas Instruments, and then another guy who later worked for Intel gets co-credit, but that's a little sus to me. Basically, these little microchips, you can see there's already a little red dot on this microchip here. Basically, they're little black boxes that are just full of electronic components that have been miniaturized and miniaturized and miniaturized, so they're very small, and they all fit in. And so this is like a whole little, like we have a green board circuit where we soldered all the pieces on there, and then we had blinking lights. All of it, all thousands and thousands of them are just in this little black box here, making an integrated circuit. And that's what Jack Kilby invented or just worked on at Texas Instruments a long time ago. All right. That's the end of it. Those are the things I wanted you to know. So I'll turn it off now.